Hi students, today I am continuing carbon and its compounds lesson from versatile nature of carbon. So what do you mean by a versatile nature of carbon? So it have so much different nature. So what is the speciality of the carbon? Let's see. We have seen the formation of covalent bonds by the sharing of electrons in various elements and compounds. In so many elements and compounds, we saw that formation of covalent bond. In the last class, I already explained what is covalent compounds, what is ionic compounds, what is the difference between them. So, we have seen the structure of simple compound like methane also. I think this one. Yes. And then, in the beginning of the chapter, we saw many things contain carbon also. In fact, we ourselves are made up of carbon also. Yes, no, the number of compounds whose formulae are known to chemists were recently established to be millions. So many carbon compounds are there along with their formulas we know. So the outnumbers by a large margin the compounds formed by all the other elements put together. What is the property? What is the unique property, special property, so that this carbon is making the 20 compounds? That is nothing but there are two factors. There are two factors which make this unique ability of the carbon to form compounds. What are the two factors? Let's see. The two factors is, first one is carbon has unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. So first property is catenation. Catenation is nothing but it can form bonds with other carbons. So with other carbon atoms it can form bonds. So many number of carbon atoms attach one to one another, forming so many long molecules or large molecules, and this property is called catenation. It can form long chains of carbons or it may form branched chains of carbons. Even the carbon atoms are arranged even in the ring forms also. In addition, these carbon atoms may have single bond, double bond, triple bond like this. So compounds are carbon which are linked by only single bonds of carbon atoms are called saturated compounds. So when the carbon compounds contain only single bond is present, it is called saturated carbon. It is called saturated carbon compounds. So when it contains double or triple bonds, if it contains double or triple bonds, then they are called unsaturated compounds. So remember this, if it contains double or triple bonds, then it is called unsaturated carbon compounds. So, what are the two types of carbon compounds it can form? If it has only one bond, single bond, then it is a saturated carbon compound. Or if it has double or triple bond, it is called unsaturated carbon compounds. So, no other element except carbon have this unique ability. So, of catenation to the extent we see in carbon. So how many carbon atoms it can form a long chain. This property is not present in others like this much extent it is not there. Even we can see in silicon, at least it can form chain up to 7 to 8 atoms. So and they are very reactive also. But carbon compound bonds are very strong bonds and they are very stable bonds. Though silicon can form up to 8 atoms, it can form chain, they are not stable. So carbon bonds but they are stable and strong bonds are formed. This gives us large number of compounds. So the first factor which make it special is catenation property. That is nothing but its ability to form bonds with other carbon atoms to give large molecules. This you should write. Then one more factor is, what is its valency? Its valency is 4. Its valency is 4. Carbon has a valency of 4. It is capable of bonding with 4 other atoms of carbon. So, because it has the valency of 4, so it can form 4 bonds with other 4 carbon atoms or other maybe other elements also like oxygen, hydrogen, sulfur, nitrogen, and many other, giving rise to compounds with specific properties which depend on the elements other than carbon present in the molecules. So again, the bonds that carbon forms with other elements are very strong. Not only carbon bonds are strong, it also forms bonds with other elements also. These are also very strong and stable. So reason is the formation of strong bonds by carbon is its small size. Why this will form that much strong bonds is the carbon is, its size is very small. So the nucleus holds the electrons strongly because the nucleus will be very near to the electrons because of its small size. That's why what happens, it will form very strong bond. So others, bigger atoms, because the nucleus is so far to the electrons, it cannot hold the electrons that much strongly. So the bonds are weak. So these are the two factors. So what are the two factors which make the versatile nature of carbon as? First one is its property of catenation, ability to form long carbon chains, and having tetravalency, means valency of 4, so that 4 carbon atoms or other atoms can attach to it. These are the two factors. Next, I already told what are saturated and unsaturated carbon atoms. Let's see this in detail. So we have already seen the structure of methane. Yes, no, what is methane? CH4, right? So another compound formed between carbon and hydrogen is ethane. Next is ethane, C2H6. In order to arrive at the structure of simple carbon atoms, first step is to link the carbon atoms together with a single bond. So ethane is, so let's see, C2H6, 2 carbon atoms are there. The first step is we should write 2 carbon atoms linked with a bond. After that is the first step. They gave first step, link 2 carbon atoms, whatever is there. Then the 3 valencies of each carbon atom remain unsatisfied. This carbon atom is tetravalent, means 4 bonds should form. Already 1 bond is formed between carbon and other 3 bonds should be formed with the hydrogen atoms. So H, H, H. Here also H, H, H. So C2H6, we can count 1, 2, 3, 4, 5, 6. C2H6, it is ethane. So the second step is going like this. So the electron dot structure of ethane is also, we can write like this, C2. So it is sharing the electrons ethane. So C2H6, we can write like that. This is C2H4. I will explain this next. So the you will see the valencies of all atoms are satisfied by single bond only. Here this valency is satisfied by single bond. Such compounds are saturated carbon compounds. Only single bond is present. So saturated carbon compounds, they are normally not that much reactive. And we will see the chain structure first, this one. So having single bond are called alkanes. These are called only single bond is present and they are called alkanes, and they have the general formula CnH2n plus 2. What is N? You can find N is here number of carbons, here number of hydrogens. So when we see first, so I will explain the first alkanes. So I am explaining with single carbon only, single bond saturated carbon compounds. They are called alkanes. So remember this, these are called alkanes. These are the saturated high carbon compounds. So methane is the first one. So 1 carbon will give meth, 2 eth, 3 prop, 4 bute, 5 pent, 6 hex, because they are alkanes, ane will come. So in the methane, ethane, propane, butane, pentane, hexane, like this, and the general formula is CnH2n plus 2, and they are called in general alkanes. This family is called alkanes. Let's see first with 1 carbon atom. If 1 carbon atom is there, it is called methane. So 1 carbon atom, it should satisfy 4 valency. So CH4, let's check the formula, CnH2n plus 2. So C1, because 1 carbon is there. So H, 2 into N is 1 again plus 2. So CH 2 ones are 2, 2 plus 2 4. So correct, right? So like this we can calculate and we can write the structure. See, one carbon is there with 4 hydrogens attached to it. So this is methane. Next, say 2 carbons are there, then it is ethane. So C2. So we should know how many hydrogens are there. Apply the formula C2H 2 into 2 plus 2 because N is 2. So C2, 2 2s are 4. 4 plus 2, 6. So H6. So here C2H6. First we should write carbon-carbon bond. First step. After that we should count the hydrogens and write here tetravalent. It should be 4 atoms should be attached. Already one is attached with one more carbon. So other 3 will be satisfied with the other hydrogens. I already explained this. So C2H6. Like this we can write. Next, third, if 3 are there, we gave the name propane. So C3 for number of hydrogens. Let's calculate C3H 2 into 3 plus 2. So C3, 2 3 is 6 plus 2. So H8. So C3H8. Let's draw 1, 2, 3. So 3 carbon atoms. 1, 2, 3. So 4 bonds are formed. Here 1, 2. 2 bonds are there. Remaining 2 bonds. Here only 1 bond is there. So other 3. So 1, 2, 3, 4, 5, 6, 7, 8. Is it satisfied? Correct? No. C3H8. Correct. Next, fourth is butane. So write C4H10. Calculated in the same way. 2 4s are 8 plus 2 10. C4H10. Again same. 4 carbon atoms you write. And here 1 bond is satisfied. So 3. Here 2 bonds are satisfied. So again 2. Again 2. Again 3. So H you complete writing H for all the bonds. Count it will be 10. So try to write pentane and hexane. Pentane is 5 and hexane is 6. Just try to write and tell me the formula by calculating like this. So next I will explain. Go on explain this. So however, another compound of carbon and hydrogen has the formula C2H4 here they gave and it is called ethene. So how can this molecule be depicted? Same step-by-step approach. Carbon-carbon link together with a single bond. Again we can see the valency per carbon atom remains unsatisfied. See here 1, 2, 3. Only 3 bonds are there. Here also 1, 3. But it wants 2 bonds. So sorry 4 bonds completely. So only 3 are satisfied. Here also 3 are satisfied. One more it wants. So it is satisfied by giving the double bond like this. Now, next unsaturated compounds having double bond I'm going to teach in the next after this. So the electron dot structure for ethene is given like this. Right, another compound of hydrogen and carbon has the formula C2H2, that is ethyne. Here also we can write like this. So we can say that carbon atoms are known as unsaturated carbon atoms because they have double bond and triple bond. They are more reactive than saturated carbon compounds. So I will explain ethene and ethane in the next coming. So don't worry, next we'll see. So already this we did. So we also understood how we can write its structure also and formula also. So in the earlier section we mentioned the carbon compounds methane, ethane, propane containing 1, 2 and 3 carbon atoms. Since chains of carbon atoms can contain many more carbon atoms, the names and of 6 they are given. So already we discussed this. I drawn 4 and I told to draw 5, 6 also. You can draw it very easily. But let us look another structure like butane. If we make the carbon skeleton with 4 carbon atoms, we see that 2 different skeletons are possible. So we wrote butane here, right? So we wrote here butane 1, 2, 3, 4. So straight chain we wrote, but we can write it as a branched chain. How we can write? Let me see. So we wrote like this, but we can write branched chain 1, 2, 3, 4 like this. We can write. Yes, no. So 1, 2, 3, 4 branched chain also we can write. Let's fill the hydrogen atoms with to this. So we can write like this: 1, 2, 3. So already 3 are satisfied. 1 here, 1 is satisfied. So 3 here also 3. So 1, 2, 3, 4. So 1, 2, 3, 4. Here 1. Here again 3. Like this we can write the branched structure. Just to look like this. See here. So this is a straight chain structure we wrote, and this is a branched chain structure. So we see both the structures will have same formula C4H10. Since these compounds having same identical formula but different structures we can write as branched or a straight chain. These are called structural isomers. What are isomers? The structures which have same formula but different structures. So they are called structural isomers, and the isomerism process is called structural isomerism. So in addition to the straight chain, it also have branched carbon chains. Even some carbon atoms have ring-like structures. For example, cyclohexane they gave. So hexane we didn't draw. Let's draw. Hexane means 6 carbon atoms. 1, 2, 3, 4, 5, 6. I draw 6. So 3 hydrogen atoms. 2, 2, 2, 2, 2, 3. So fill the hydrogens. This is hexane. Normal hexane. So hexane means 6 carbons should be there. Pentane means 5 carbon atoms should be there. So even we can write it as a ring structure. How to write a ring structure? Let's see. So this 6 carbon atoms, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Like this we can write and fill the hydrogens like this. So 1 carbon is bonded with 2 hydrogen atoms, so that its bond is satisfied. So this 2, 3, 4. So 4 tetravalency is matched. So this is cyclohexane. So next, can you draw the electron dot structure for cyclohexane? Yes, we can draw. Straight chain, branched chain and cyclic carbon compounds all may be saturated and unsaturated. For example, if you see benzene, it is a cyclohexene structure because it has double bond C6H6. While I am explaining the next family alkenes, I will explain this. So I only explained alkanes which are saturated hydrocarbons now. So all these carbon compounds which contain only 1 carbon and hydrogen are called hydrocarbons. Here we can see only carbon or hydrogen bonding, right? So that's why they are called hydrocarbons. Among these saturated hydrocarbons are called alkanes. Now I already told these are alkanes. Saturated hydrocarbons means having single bond, and I already explained the structures of all alkanes, 6 alkanes, and the unsaturated hydrocarbons which contain 1 or more double bonds are called alkenes, and triple bond are called alkynes. So remember, saturated hydrocarbons contain 1 bond, 1 single bond, single bonds. So single bonds are alkanes. Double bonds, having double bonds are called alkenes, and triple bond are called alkynes. Like this we can tell. So alkanes, I already told the general structure of alkanes, CnH2n plus 2, its formula. So I will in the next video I will explain alkenes general formula, alkynes general formula, which is not in your textbook, but it is important for you to learn. So to understand the structures of ethene, they gave in the textbook, and also benzene. So continue to watch this video in the next part also. Thank you.